different equations that we know. Two different equations that we've been playing with. The first one, the general form of a quadratic equation that we've had for a while. So you've got ax squared plus bx plus c. Can we just do something to this for a moment? I want to have x squared all by itself. So to get x squared all by itself, what do we need to do? Well, we need to get rid of a. How can we get rid of a? We could divide everything through by a, right? So you divide every single term by a because I want x squared all by itself. So divide ax squared by a and you're left with x squared. Then I have to divide this term by a and you're left with b over ax. Then you have to divide the constant term by a and you've got c over a. If you divide 0 by a, what are you left with? Just 0. So this is an alternative or a rearrangement, I could say, of the general form of a quadratic equation. Are we okay with that? All you've done is divided by a. All clear? You might go, why? Well, we'll see in a moment. Now let's come down. I'm just going to scroll down a little bit. Alpha and beta. And what is going to be confusing before I go on is what we're about to do. We're going to be working with alphas, betas, A's and B's. So can you please make sure that your A's and your alphas look very different? So for your alpha, maybe do it like a fish, or I tend to just do like that. Whatever, but you've got to make your alpha look very different to your A. And when it comes to tests, etc., you need your alphas to be very different from your A's. Because this question, in one question, you can be working with A's and alphas at the same time. Okay? So make it like a fish or make it somehow with a very curved on the end. Okay? Now your betas, well, a normal B, beta is going to be like that. And to even distinguish it more from a B, feel free to make the stem just that little bit longer. You need to be able to distinguish between them. Okay? Let's get back to this. Alpha and beta are the roots of a quadratic equation. So if they're the roots, we could say this. Right? Because the roots of any quadratic equation are exactly that. When you have them, when you factorized it, it is obviously the negative or positive version, the opposite of what is inside the brackets there. So a minus 1 root, brackets x minus the other root. So is that okay? We understand how that is how we could write two roots in an equation. Great. Well, let's expand out the brackets. If I expand out the brackets, I have x squared, then I have minus alpha x minus beta x. When you multiply two negatives, you get a positive, so you have alpha beta at the end. And then I could collect the coefficients of x, which is things that we were doing last week. So if I do that, I have minus, then in brackets, alpha plus beta x. Is that okay? You've just followed what I've done? Yeah? Now this is the key thing. I've written these equations in the same form. But in one of them I've used A, B, C. The other one I've used alpha and beta. What is alpha and beta? I said it just like before. Alpha and beta are they're the roots of the equation, whereas A, B and C are the coefficients of x squared x and then the constant term. So in other words, these equations are equivalent, but one is in terms of the coefficients, one is in terms of the roots. So we can say that looking at the coefficient of x, we can say that alpha plus beta equals minus b on a. Does that make sense? What we've done is we've just looked at we've got these equations have to be the same. They have to be the same. So in other words, you add the roots together. When you add whatever the two roots are, it's got to be minus the coefficient of x over the coefficient of x squared. Okay, now if we are to multiply the roots together, well, over here, the constant term is actually the product of the two roots. Whereas up in this form of my quadratic equation, the constant term is c over a. So in other words, the product of the roots is the same as the constant term over, what's a? The coefficient of x squared. Does that make sense how they have to be equal?
Yep.
Okay, so we're going to be working with these and getting used to the sum and products of roots. Here it's summarised really nicely in one box here. So if alpha and beta are the roots, are the two roots of this quadratic equation, then we can say that alpha plus beta is negative b on a, and the product of alpha beta is c over a. And then it's got it in words as well. So you might want to just have these